Today, I will be discussing the details of security architectures and hardening practices of two modern operating systems, which are Microsoft Server 2022 and Ubuntu Server 24.04 LTS, along with two commonly used host-based firewalls, which are Windows Defender Firewall and Linux IP tables. The goal of this presentation is to focus strictly on the technical design of these platforms and how we can harden them against threats. Windows Server 2022 has moved toward what Microsoft calls a secured core server model, which provides a baseline of built-in protections. One of the most important components is virtualization-based security. This isolates sensitive memory regions from the main operating system, which makes it harder for malware to tamper with kernel-level secrets. On top of this, Microsoft also has hypervisor-enforced code integrity, which is also known as memory integrity. This ensures that only trusted signed code can run on the kernel level. Credential Guard is another key feature of this operating system. It stores authentication secrets in the protected memory space, which reduces the impact of credential theft attacks. Finally, the modern SMB stack in the Windows Server 2022 allows encrypted file sharing and stronger encryption options like AES 256. These updates make remote access and data transfer far more secure, especially for hybrid or cloud environments. Windows Server 2022 also integrates multiple defense in-depth components. For example, Windows Defender now includes attack surface reduction rules, cloud-delivered protection, and tamper protection. These help to resist malicious modifications. On specific supported hardware, Secure Boot and TPM 2.0 measurements provide firmware-level integrity checks and secure key storage. In terms of policy and management, Microsoft has provided security baselines through group policy, which organizations can adopt and customize. These baselines enforce best practices for things like password policies, audit settings, and encryption defaults. Finally, Windows Admin Center helps administrators monitor and enforce secured core features, which provide a centralized interface to manage compliance. For Windows Server 2022 hardening recommendations, firstly, it's always recommended to adopt the Microsoft Security Baseline for Server 2022 as your starting point and tailor it to your specific needs and environment. Second, make sure that you enable the VBS, the HVCI, and Credential Guard wherever your hardware supports it, because this significantly raises the bar against privilege escalation. Third, disable legacy protocols and weak ciphers, and ensure all your policies are modernized. Fourth, apply the attack surface reduction rules and consider whitelisting applications with AppLocker to reduce the chance of unapproved software running. Finally, for data at rest, enable BitLocker encryption and a PIN for sensitive workloads, which provides a physical security assurance. Ubuntu Server 24 is built on the Linux 6.8 kernel. Its security is tightly integrated with AppArmor, which is enabled by default and provides mandatory access controls. AppArmor profiles restrict applications to the bare minimum permissions that they need to function. Ubuntu also includes unattended upgrades, which lets you automate security patching. This is helpful for organizations that need maximum uptime. Live patch service can also apply kernel updates without rebooting. The platform also aligns with modern crypto standards, ensuring strong defaults for things like OpenSSL, OpenSSH, and systemd. This makes Ubuntu highly suitable for secure servers and cloud workloads. Ubuntu also comes with robust auditing and compliance tools. For example, the auditd service allows detailed tracking of system calls and user actions. Ubuntu also integrates systemd security directives, which let you sandbox services individually. These options can help isolate processes, limit file access, and reduce the impact of potential exploits, just to name a few examples. Some recommended hardening practices for Ubuntu are to first minimize your attack surface by removing unnecessary packages and services. Also configure app armor profiles in enforce mode to lock down critical applications. Second, I would enable and monitor unattended upgrades. If downtime is an issue, consider the live patch service for kernel updates. Third, harden the SSH and disable password authentication, enforce key-based login, disable direct root login, restrict access by subnets, and consider adding multi-factor authentication. Fourth, enable AutoD to capture key events and authentication, and then you can forward these logs to SIEM for monitoring and integrity checks. Finally, you can leverage the systemd sandbox to limit privileges of custom services. Windows Defender Firewall is a host-based stateful firewall that integrates tightly with IPsec for authentication and encryption. Windows Defender Firewall uses three profiles: domain, private, and public. These three profiles allow administrators to apply different levels of security based on the network environment. These rules can be very granular, target specific applications, services, ports, protocols, IP addresses, and even specific users or computers. The firewall also supports detailed logging and auditing, and its policies can be deployed through group policy for consistency. Behind the scenes, Windows Defender Firewall relies on the Windows filtering platform. This is a set of APIs that filter traffic at multiple layers of the network stack, including application, transport, and network levels. One of Windows Defender Firewall's biggest strengths is its integration with Active Directory and group policy, which allows organizations to enforce standardized host isolation rules across thousands of systems. Windows Defender Firewall can be managed through PowerShell or a GUI tool like Windows Admin Center, which gives administrators flexible ways to automate and control firewall policies. For hardening Windows Defender Firewall, there are a few key recommendations. First, enforce a default deny inbound policy, which allows only explicitly defined application imports. Second, prefer per application rules instead of broad port-based rules, and tie them to service SIDs when possible. Third, use IPsec isolation for sensitive systems, which requires authentication and optionally encryption to prevent unauthorized movement. Fourth, enable firewall logging and auditing and forward those logs to a central SIEM, and then you can monitor and alert on unexpected changes. Finally, in high security environments, manage the Windows Defender Firewall exclusively through group policy and disable local administrators from merging. IP tables is a user space tool that interacts with a netfilter framework in the kernel. It uses tables and chains to control packet flow. Some of the more common tables used are filter, NAT, mangle, and raw, and security. IP tables supports stateful inspection through the connection tracking module, allowing rules based on states like new, established, and related. IP tables also provides NAT features such as DNAT, SNAT, and masquerade, which enable port forwarding and address translation. Performance can be optimized by careful rule ordering and by using IPset for a large list of IP addresses instead of a long rule chain. For redundancy, tools like Contracted allow synchronization of connection states across multiple firewalls, supporting high availability clusters. In short, IP tables remains powerful, flexible, and widely deployed, even though NF tables is a newer framework. Hardening IP tables is all about minimizing risk and performance overhead. Firstly, we would adopt a default drop policy for inbound and forward traffic, which allows for only explicitly defined traffic. Second, use IPset for managing large allow list or block list, and optimize rule orders to match the most common traffic. Third, implement rate limiting for high-risk services such as SSH or ICMP, and consider SYN proxy to mitigate SYN flood attacks. Fourth, restrict administrative access by limiting SSH to known management IPs or subnets, and segregate the management traffic onto dedicated LANs where possible. Finally, avoid disabling connection tracking unless absolutely necessary.